Hello everyone, my name is Ben and you're welcome to my C programming language tutorial. This is Hackpace and we talk a lot about technology, all that has to do with technology, different languages like the C language, assembly language, which are low level language. Most times also we talk about Python, which I have not yet started, and most especially the one and only language that is a compulsory for everyone to learn, which is a bash scripting that allows or give you the ability to work comfortably in the Linux environment or CLI. Okay, so what this program is going to be all about is a program that will display our digital clock. Okay, our clock based on our time zone or based on our country. For example, my name is Pen and I'm in Nigeria, so if I run my program, this is what's going to happen. Okay, it's going to tell me the time zone just like this. My time now is 3:05, which is 5 minutes after 3. Okay, so this is early morning. Today is Wednesday early morning, and you can see it over there. So what this program is going to do is that despite anywhere you are, your country, like being space, is going to give you the actual time zone of where you are. Okay, so this program is going to be more real and robust. Okay, so you can use this program as well to build other stuff, because I'm also gonna add a features into the program which has to do with a clock that will just start from zero, like the seconds keep ticking the seconds and giving us the minutes and the hours. Okay, it has been running. Okay, so it's gonna based on choice. If you choose to get a digital clock, it will give you the current time. If you run it again, everything changes, it give you the actual time. If you run it again, everything change, it gives you the actual time. If you decide to choose the current flow of the clock, it will display and keep counting the seconds. Why 60 seconds is equals to 1 minute, 60 minutes is equals to 1 hour. So it's going to keep counting until you stop the program. So this program is something everyone need to watch, so please make sure you invite your friends, and as you're watching this video, make sure you hit on the subscription button, turn on notification bell, and drop comments on what you don't understand or how you feel about this program. Okay, so without further wasting of time, let's dive straight into what this program is all about. Okay, so I will just clear the screen by doing Ctrl L and then Ctrl U to wipe up this welcome text. Okay, I will use the mkdir to create a directory, and I'll call this directory clock. Okay, because the program we are creating is a clock, so I press my enter key. So I just create a clock directory. Okay, all right, I just click a clock directory. Sorry for that, we just pop up. Okay, so I'll just do the cd command into clock. All right, so now I'm into the clock directory. You can see it here. The clock is now in green in the same line prompt, okay, which is the ps1. all right, so next is creating file. Use a touch command to create a file. So we call this file, what name should I give it? Maybe digital. I think, yeah, it should make sense, digital, because it's going to be a digital clock. That spelling is wrong. Digital should be spelled digit. So I'll just spell digital.c. okay, or I'm supposed to say digital clock.c. okay, and in our next video, maybe probably we might decide to write a program of analog clock. Okay, the normal clock we have in our home, okay, that has the counting hands and the minutes, legs, and all that. Okay, but for today we are going to be writing about digital. So I'll just press my enter key and that file is now created. If I type the ls command, which stands for list list content of this current working directory, so I press my enter, then you see it lists the file stored in it. Now we have the digital underscore clock.c. all right, so we use the Vim editor, which is my best editor, is a CLI editor. CLI stands for command line interface. Okay, so what Vim is a very well known, used by professionals, programmers in low level or even high level, to build web applications, to build software system application, operating systems, and so on and so forth. So it's something very, very beautiful. Everyone like using Vim. Okay, and it allows you it gives you this feature of keyboard shortcuts which you can use to navigate through directories, files, and edit files, change files, and a lot of stuff, okay, about Vim. So if you are interested in learning Vim, there are a lot of PDF documents out there that you can get and use it to learn the Vim, and keep learning, okay. Don't be frustrated by the errors you get while you are using Vim, but just keep pushing the button and keep learning, okay. So we're just passing the name, the digital clock.c, and press enter. Now we are in the Vim editing mode. If you look at the bottom here, you will see digital clock.c, okay. So if I press my enter key, it will change to what we call insert text. It will change, and what you will see there now will be insert text if I press my I key. So you do the same by pressing I. Now you see we have what we call insert at the bottom there, okay. So insert gave us the ability to write to this file, okay. So we are now writing to digital clock.c. So we start including our header files. So I will include the stdio, which stands for standard input, okay, and output.h, which is a header file where so many functions are already defined, okay, which our code will be referencing, okay. So please, as you are following this video, make sure you are using a Linux machine, okay. If you are using Windows, make sure you have WXL or WXL2 installed in your Windows, and install Ubuntu alongside, or Kali, or any Linux distro. You are fine to follow up with this video. But if you already have Linux, install direct to your machine hardware, and that is very, very okay as well. So that is our number one header file. We also gonna include more header files, like they include, okay, we'll include the time.h, okay, which helps us to access the structure, okay, of the time and other functions of the time header file, okay. So press enter. That's not all. We're also gonna include the unit standard, or as better include run, guys. So include unistd, okay, because we, anytime the clock starts, okay, we need to clear the screen so that everything can start fresh. The screen don't need to look garbage and all that. All right, so I'll just do .h and I close it. So I want to put .g, should be .h. all right. Oh, sorry, well, .h, yeah, that's correct. All right, okay. When I'm writing code, typing errors, most of the errors I face, okay, is this only what we need? Okay. All right, if there are more functions or other files we need, when we run our program, if we get any error, we just come and fix it, okay. All right, so type the int, we say main, okay. I'm not receiving any arguments from the command line, so I'll just pass in here void. All right, open curly brace, enter, and press enter 2 times and close the curly brace. At the top here, tab, return. We call this skeleton code, okay. Every C program must have a main functions, okay. If you write a C program that don't have a main function, it will compile, but it can't execute anything as an output, and the program counter of your CPU will know where to start executing the program, except that program is being called into the main program. Maybe that program may be a sub program or a sub file that need to be called into the main program itself. So we need this main function, and at the top here we are going to also define other functions that will help us in our journey of writing code. All right, so press enter. So I'm going to define a function which should be of type void, and I will call this function, I will say time underscore count, okay. That should be the name of the function, okay. Should this function receive argument into its parameter? Okay, let's say no, we don't need anything, so I will just pass in void as well. So we are not accepting anything, so both the pass in parameter and the return value are void because we are not accepting anything. We will press enter, okay. So again, we are going to also say void menu, which gonna be the menu that will be popping up in the screen. So it's not receiving any parameter as well, so that's it. We just pass in void. Anytime you're writing a C program, it's not returning anything, it's not accepting anything from into its parameter, make sure you pass them void. Okay. The last function here will just be void, okay, as well, and it should be called clock, d clock, which stands for digital clock. So I will say d underscore clock. Okay, I want to say dc, say d underscore clock. Okay, and is not also accepting anything to its parameter. So that is it. Okay, so these are three functions we just write, which these are called function prototype. Okay, we can put this in separate file, but today I just want this program to be just easy. Okay, very easy. All right, guys, so there won't be much edits on this, so I'm just trying to build this to be a very simple programs. All right, so what we do now is we go to the bottom of it and declare and give the definitions of this function. So the first one is the name is time count. By looking at the name, it has already stated what it's doing. Okay, let me don't say d clock, so people might also understand what it is. So let me say digit. Okay, digital clock display, digital clock underscore display. Okay, a friend of mine told me that it's best that you give a very well-known name to a function or variable declaration, so that you don't need to be putting comments everywhere. Just the name itself will tell what the program or the function is all about. Okay, so the digital clock, by looking at it, the name, you know that this is a function of a digital clock. So when you look at here menu, you know that this is a function that will print menu, and this will be a digital a time count, let's say underscore clock. All right, yeah, I think now everything is looking very nice. So let's start writing each of these function. So we go down here, we have to pass in the parameters, returns, and we have to define it the way we declared it. Sorry, so we say void, and the name is time underscore count. Okay, I can say timer. Say time underscore we say clock, right? Is that how it's been spelled? Sorry, clock. So we open this and we say void, because we do not accept anything to this parameter. So the next thing is space. We do it like this, and we close our curly brace. So that's it. So what next is we need to start writing this function, what this function is going to be doing. So I press my tab key. Okay, time count is going to be a function that we count, okay, and give us the output, and as it gives us the output, it also flush its buffer, that is written to the standard output. Okay, so we have to declare I think we have to declare seconds, comma, minutes, okay, comma, and we also declare hours, each hour, okay, semicolon. All right, so this is the variables that we hold each of the seconds, minutes, and hours that will be counting. All right, so I think this is okay. So our next is we're just going to dive into a while loop, an iteration loop. So this iteration loop we use, it will be a forever loop. Okay, so I will go at the top here as well. I will just do a hash define. I will call this true. Okay, I will say true. All right, true. I'll press my tab key and I'll say 1. Okay, so which means that this program will execute forever. So we pass in this true into our while loop. in this place. Yeah, so instead of passing one that will confuse you guys, so let me just give an identifier to these two. So it was given uppercase T RUE. Yeah, that's the name. So we close that and open curly brace, enter, and close curly brace. Yeah, so inside this while loop now will now contains how our program is gonna be running. Okay guys, so first is when this program runs, so it's gonna start counting. Okay, that's what it's gonna be doing. It's gonna start counting. So we are gonna be printing first to the screen using the printf function. Okay, yeah, we are gonna be printing first. Okay, open bracket column percent instead of D, because every number, this is how it a number should look like. For example, if I just give a comment up here, for example, I'll say this number will look something like this. I'll say 00 column 00 column 00. You know, this one is the seconds, this one is the minute, and this one is what, the hour. Okay, so this is gonna look like. So let me just leave it here as a comment though, okay, so that you understand what this loop will be doing. Okay, so that you guys understand it very well. So that is what I'm going to pass here. So for me to get this 200, I will say here 02, because I say I want two values here. Okay, so I will now do D. All right, it's supposed to be colored. Why? Because we do not give our double quote here, so when I see that change, which is nice. So I'll put a column here again, and I'll do %02 and D. Okay, and this again we say %02 and D. All right, so that's it. So we like this to be printed in, first of all, we like to have a two new line. Say not, we don't need a new line though, we just need a single tab, so /T, so you can maybe leave move out of the screen and just look nice. Or we can give a double tab here. Okay, so it fits the screen center. All right, so that's it. All right, so I'll just close this. I don't think there's a need for a new line here, so I'll do once the program encounters, yeah, we should put a new line. I think that will be okay. If that give us any problem, then we just, if that give us any problem, we just have to come and fix the problem. So yeah, I'll do comma, or pass in sec. No, the last one should be the hour, so we'll pass in hour first, each hour. Okay, I'll make the screen a little bit smaller so that it fits nice and good looking. Hour comma minute. Okay, so this first one here will be our hour, and this one here will be our minute, and this other one will be our seconds. So at the end here we just pass in SEC. Okay, make the screen a little bit smaller again, and we close that. Okay, and put semicolon. So that's what this is gonna be doing. All right, so that is pretty good looking. And next thing now, we need to start, we need to do what we call cache. We need to flush the cache of the buffer of standard output, because this is what will be read to the buffer, which is our screen, our prompt. So we use the ff function called fflush. So we pass in the standard output. Standard output is declared and defined in the, I think, in the stdio by default for us. So if we do not declare it, we'll come back and declare it ourselves. That is pretty very easy though. So we say stdio out, yeah, and that is it. sorry, and that is the semicolon. So we flush the cache, okay, and that's it. So next thing, now we can now start if statement to shake seconds. We'll now say seconds. Once we flush the cache, it will be good that we increase the clock. Yeah, we are supposed to increase the clock here. We say sec plus plus. All right, let's put this in a different line though. Yeah, so sec, we do semicolon here, and we start our sec. Okay, sec is incremented. We say if it's equal to 60 seconds, because 60 seconds makes 1 minute. So we say if it equals to 60 seconds. Okay, we close this and open curly brace, and oh, that was not curly brace. So open curly brace and I'll press enter. So 60 seconds should be what it should give us. So every 60 seconds we should increment the minutes. Okay, so here we'll now say min. I'll be using what we call assignment operator. So I will say min plus equals to 1. You know, this simply means this I just this simply means min, okay, equals to min, okay, plus 1. Okay, that's what this code is simply means. So I'll just leave this comment like this. All right, so that's it. So I'm supposed to put semicolon at the end here, so I put semicolon. Okay, so once it's done, then we say seconds. We say sec is also, it's now, we will now be equals to 0. Okay, so it's going to start again, start counting again. So seconds should be equals to 0. Press enter, and we close this curly brace, and that is it. So we can do else if again. Well, we don't need else if, we just do a normal if again. So we say this time is minutes. So if minute is equals to 60 seconds, and you know 60 seconds is 1 hour. Okay, it's 60 minutes. 60 seconds is 1 minute, and 60 minutes is 1 hour. So we do it this way. We say now minute, then we means HR. 60 seconds, 1 hour, 60 minutes equals to 1 hour. So we say HR will be HR will be H plus, sorry, H will be H plus equals to space 1 semicolon. So I'll just comment it again for what it means. HR equals to HR plus 1. All right, I hope that is clear as well. So once we are done with these things, then we say minute will now be equals to 0, and that is it. We close this. Then the last one, which is hour. So we say if, open bracket, we say HR if is equals to 24 hours, not 60 anymore, because in every fly we have 24 hours. Okay, so we say 24 hours, which is, it makes us a day. So we say if 24 hours, okay, then what we are doing is we are going back to 0. Okay, if every 24 hours we are saying the hours now should be HR should be equals to 0. Okay, and minute also should be equals to 0, and the seconds also should be equals to 0. I guess you get what this is doing. Okay, we are like now sending all of them back to 0, that we have reached a day. So the day is refreshing at 12 midnight 0. So at that 12 midnight is 00. So everything should be 000. Then it start counting by itself again to give us the appropriate count. Okay, I hope you guys are not confused of this. So it's just a very simple stuff. All right, so CPU need to relax, because we need to make the CPU relax. Okay, I'll be using the time function called sleep to allow it to slow down in every 60 seconds. So 60 seconds is 1. Okay, so I pass in 1. Okay, so that's how the sleep function is being created. So this program will help us, okay, arrange things accordingly. Okay, so that's what this function is gonna be. So that's it. So the next function we're gonna write now should be of void, which we're gonna shake the name up here. It says void menu, so we're going to write our menu function. All right, so we say menu, mnu is the name, and make sure whenever you're writing a function you don't put space the way we do in the if here. Okay, we put x here because if is a keyword and this is an expression here, so we are checking for condition here. If we join it together, like this, there won't be any error, but it's a very bad code style, so we are supposed to like give space here like this. All right, so in function, okay, you join them together to tell that this is a function. So this function accepts nothing, so we'll pass in void. Any function that does not accept anything, make sure you pass it void. I think that's the best in your function declaration, which is the prototype, the way we do it up here. But in your definition, you also do it. But while you are using it as a written function, you don't need to pass in void. Okay, you just do the open and close brackets, which we see how we are going to do it in this video. All right, so open curly brace, press enter key, enter again, and close curly brace, and we go up and press tab. Now we start writing our menu. Okay, so the menu will just be a very simple printf function. Okay, just be a very simple printf function. All right, so we use the print function, the printf, to write it. So I will do double quote, I will do asterisk. I just don't know, I just like using this to design this thing. There's also other ways you can do this as well. Okay, there are other ways you can do this. All right, but for simplicity case, then for just easy design, let me just pass in asterisk. Okay, so we'll just do it like this. I think this is okay. So I'll do new line, then I'll close this, and I put my semicolon. So I just typing this thing again, we make our video more long. So what I will do, I will copy. How to copy this text in Vim? You press your escape key. Now you see the insert the insert is no more, so we are in escape mode now. So in the escape mode, I can just move my arrow. Okay, I can move my arrow up, down, but I can't press anything. So what I will just type is YY. Okay, YY is for yank, which means copy this line, this entire line. So if I press YY, now I've copied it. Okay, so I will just go to the end of this code. I can't move above the end, so across the end, sorry. So what I need to do is to press the I insertion mode for the insertion to come back. Now I can move at the end. I can now press my enter key to move to the next line. Then for me to paste that which I copy, I press the escape key again to go back to the normal mode. Then now I can now press my P. Okay, how many times I press the P is how many times it's going to display this. So I press P multiple times, and that is it. I press my escape to come out of this, and my I. Now I can start writing my code. I hope this is very clear and understood. So what I will now do now is here, I'm just going to clear some line here. So from here I will just clean. So I will say menu, and I'll give space. So I'm just gonna do this way. Yeah, I think it's okay like this. I just have to like clean more lines. I think it's okay now. All right. So menu, yeah. I want this to just smash. Okay, yeah, it now looks okay. So we now start deleting all these ones to make it fit and look I think beautiful. Yeah. So the next one, I do the same thing. So here now I will start writing what we want. So we say um time clock count. We say clock count. Okay, so this is just a clock count. All right, so I will just move just to make this look okay. Now it looks okay. So number one should be 1. If you press 1, that should be for clock count. Okay, so if you press 1, 1 will be for clock count. Okay, so I'll just clear this. So 1 will be for clock count, then here should be for 2. If you say 2 should be for I think the digital clock. Digital clock. Yeah. So 2 should be for digital clock. I think this is okay. All right, so it now looks nice. So we go there down here, and we give this and put it like this. Then we go to here and put the last one. If you choose 0, okay, if you choose 0, and this should be for exit. You see the exit. Oh guys, sorry. All right, so let's move back a little. Okay, so if you choose 0, 0 should be for exit. Okay, just move here to make it look okay. So that's it. So I press my enter key again. I press escape to paste another one. Sorry, escape to paste another one and another one. Yeah. So I press I for insertion key and I just join this. All right, so this is it. So this is a very good looking display. So we are done with writing this nice looking function. That's all we need. Okay, so we press enter key again, and the other function, which is I've forgotten the name, let me look, it's like digital clock display. Yeah, digital clock display. So we write the digital says digital underscore clock underscore display. Then we open this, and remember that we are not passing an argument, so pass void. So, and that is it. We write our skeleton, close, and go up and press tab. So now this digital display is the one that is going to display the actual clock that will give us the actual time zone if we select digital clock. Okay, so the digital clock has its own functions that are written, like the local time. You know, it has a structure of which you can declare structure of current time and all that. So that's what we're gonna do first. We are just gonna create a variable called insec comma mean. Okay, comma mean comma hours. Yeah, so press enter. So the next one is we are gonna use the time underscore t type to declare x. Okay, then once we are done with that, we are now declaring a structure that we point to the structure declared variables. this structure will be of pointer, so we can call it time m, which is time, can call it maybe time interval, time v. Yeah, let's call it time time v, time interval, or we can just call it t though, time. Yeah, I think it's okay. So we say asterisk. Okay, this, we give it a name. No, it should be called, no, it already have a name though, declared. So I think the name is tm. Yeah, if it's not tm, we'll just come and fix it. Okay, tm, then we'll give our own current underscore time. Okay, then semicolon. So we use this current underscore time for doing our stuffs. So we're going to say current underscore time should be equals to the local time. So the local time function we are going to use, and local time function, we accept the address. Okay, we accept the address of s, which is our time here variable. Okay, so that's what it's going to be doing. All right, so I'll put our semicolon, I'll press enter. So in this address, whatever that this address is returning will be stored in the current time. So this address is returning the current time. Okay, so this at the current time, it will be the time in minutes, time in seconds, and all that, based on the pointer of the structure. So we are saying, first of all, we are getting seconds. We see seconds is equals to current, whatever current return as a time, which is a pointer. Okay, is a pointer to tm, yeah, tm on see a current pointer pointing to tm, which is this structure pointer. Okay, which is this structure pointer pointing to tm, and the tm also should be pointing, okay, should be pointing to no, it's not pointing. We say he himself is, the current time is, okay, yeah. Yeah, sorry guys. So the current time, the tm underscore, since it's minutes, we say underscore, is it sec? Yeah, I think sec is the name, or seconds. Actually, let's say sec first. So if we get error confused, so we'll do the minutes equals to, what's happening is that this current here, we have already taken it at the structure, so this current time is also pointing at this structure. Okay, so we say this structure, which is this tm, we go down, we say, since this structure current time is now holding the value returned by the local time, and I say whatever value we are returning, we say current time, or we do not put the current time, we say current time pointing to this, whatever in the content of the structure called time sec. Okay, called time sec, which is seconds. Okay, so we also do again, and the return value will be stored in the seconds. Now we are doing the minutes, so we also say current, which is our structure, current, okay, underscore time, which is our structure, should point to the tm underscore main. Okay, I think that's it. Then hr, which is for hour, is equals to current underscore time, okay, should point to, okay, we can put space here if you don't understand this, to make things more clear. So that is pointing to this. Okay, so it's pointing to, why we are using this arrow pointer is because we say this current should be a of type pointer. So if we're to make, if we're declared to be, it was declared by those that declare it to become a, not to have this asterisk like this, then what we are supposed to use is the dot operator. Okay, but because it has asterisk, we'll be using the arrow pointer. Okay, so we say, we come down here, then we say tm underscore hr. Is it hr or just hour? Maybe we should just pass in hour. put semicolon. That should be the actual name, I guess. So this is it. So once this is done, all we now have to do is to start using the print function from the stdio printf. Okay, so we are now printing to the screen using percent sorry, percent 02. Okay, that is 302 and D. All right. We can just also put this as put double tap just for it to be in the middle of the screen, just the way we did this up one. Okay, this one, remember, was it here? Yeah, it was here. So at the top here, this is what we do it. We put two tab here, you can see it. So let us just make it look like that too. So we'll put that and space column percent 02D column percent 02D. Okay, so new line. Okay, so now we pass in the first one, which is HR should be the first one we are passing. Okay, HR, which is this HR result we go here, and the minute we go here, and the seconds we go here. So HR will put comma to separate them, say minutes, comma, and sec, and we close this. So this is pretty much what this should be doing. Yeah, so that is it. Okay, so we are not returning anything, so this is what the function should be doing. The function of the time is this look pretty good though. So if there's any error here, we'll just come back and fix it, but I believe there's no error here though. So now it's time to start making use of these functions. Okay, start making use of these functions. So now we'll now come back to our main program, which is this. Every C program must have a main program. So this is what we actually tell if we write any program. Okay, and this is where our program will start execute. So let me just comment it. Say asterisk, say program counter, or we say CPU program counter. Say CPU program counter execute from in main to execute main. Okay, so that's it. Asterisk /. So we'll press my enter key. So now what we are gonna do now is, first of all, we run this program. The first function we'll be calling here is the clear screen function. So I will use the system function. Okay, so we are calling the clear, which is already in our system. Okay, we say the clear. All right, and we'll do it like this and semicolon. So once we are done clearing the screen, the next thing is to choose which program we want to execute first. Okay, so we say I would like the program to install stuffs. Then after it installs stuff, it clear the screens and print the name of this program first. Oh no. Yeah, let it, after clearing the screen, first of all it display the menu. Yeah, so pass in the menu just like this. This is what I mean, that we don't need to give any argument, we just pass it just like this and semicolon, and that's the menu. So the menu is being printed, so we need to make a choice now. Okay, either we are choosing clock count, or we are choosing to get the actual digital clock to see the time zone of where we are currently in. So first of all, I will use the if statement. Okay, at the top here we'll create a variable first. So we say I'll create a variable of int. I'll call this ch. All right, oh no, I'll call this n. Okay, a variable of n. So whatever n is, so n is gonna receive input. So first of all, we use printf to say printf. Okay, say print, say \n we need 2 line, and we say please, let's say enter choice, or we say choose your choice, choose just it be choose your choice, choose by pressing, choose by entering, let's say entering, choose by entering 1, or we say 0, open curly brace, square bracket, we say 0 to 3 to 2. Okay, so we have option of 0, 1, 2, so we should choose from this. So whatever you choose, we determine you should have been not choose choice, should have been enter choice. Yeah, enter choice, that should be the right English here. We say enter choice. Yeah, I think this is the right English. Okay, so we close this semicolon, and the next thing now we use is scanf. Okay, we use the scanf, or we can also use the get sha if we want. Okay, we can use scanf, we can use get sha, anyone we want, but let's use the scanf for simplicity. So we use scanf percent %d, close this comma, I will pass in the address, all right, of n. So we are scanning it into n, and that's it. So the value we scan in will determine if we are going in or not. So we are not saying choice, we want to check if you enter any of this. If you do not enter any of this, enter choice, we want to say if you enter 1, if you do not enter any of this value, then let it print that incorrect value and terminate the program. Okay, so we say we use an if statement. We say if n, okay, is not equals to 1, all right, or put or n is not equals to 0, or we say or n is not equals to 2. Okay, if n is not equals to any of these number, then we are exiting. We would like to print to the screen. We like to print to the screen. Say wrong choice. I have to say let's say wrong choice, maybe wrong, incorrect. Yeah, I think incorrect will be okay. Yeah, we say incorrect incorrect. Wow, can't even spell incorrect anymore. Wow, what's wrong with me? Incorrect input. Incorrect input. Then we put new line, which is \n, and we close this, and we call the exit, and we say we are exiting with failure. So we say exit will be in uppercase. Exit, we say exit underscore failure. Okay, and that will just quit our program for us, and we close this. So but if it's any of that, okay, then we are using the switch. Okay, we are using the switch, okay, we are using the switch. Okay, so the switch will now pass in n, okay, which is the number we enter. We are not supposed to close that, we terminate that. So open. So we are now saying, okay, we are now inside the switch. We use the switch sub case. Then we are saying case we enter 1. Let's put 0 first. Case we enter 0. Okay, then we are saying exit. We are calling the exit function. So we are saying we are exiting success. Okay, we are exiting success, and that's good for us. Okay, so but we say if it is not case, maybe probably is 1, then we are saying we are now calling 1 should be I think if we look at the main menu, 1 is clock count. So that means if we choose 1, we are going into clock count. Then here now we will now call the clock count function. So we say what's the name of clock count. So I could have forgotten the name. It's called time. We call time underscore clock underscore count clock. Say time underscore count underscore clock, and remember it accept no argument, so we just open and close, and that is it. Okay, then after that, let it execute something. We say if once the time clock say, we say if we create a variable to say if we encounter such kind of program. Okay, if we encounter such kind of program, like for example, if we encounter a new line, let the program terminate. Okay, let the program terminate. Okay, let it terminate successful. So if you just press enter, once you are done, you can, or you press Ctrl D, the program terminates. So we say a variable of, it should be of integer, so we declare it as well here. We say we call it ex, which stands for exit. Okay, so we say if ex is not equal to, it will always be true if it is not equals to end of file, or if it's equals to end of file, then the program terminates. So we say if it's equals to end of file is control, if it's equals to end of file means Control D. to stop our program. Okay, so we press enter, then we are calling the exit function again. Okay, we say exit underscore success. Okay, and we close it with semicolon, and that is it. So the next one is the other case. We say case 2, which is our last case here. We say case 2, and the name is digital underscore what is the name again? Is it digital clock display? Yeah, digital clock display. I could remember that. I remember that one. So it should be digital clock underscore display. So we open the query, and that is it. Put semicolon, press enter. We are now saying again, okay, if this will just end once it is you give us this. We say just return once it encounter this, so we just stop here. The program just stops, so we just break out of. Once you encounter here, we just break it. We say break, we just break. Okay, we didn't break here because this is a count wash, so we want it to accept something first. Okay, if it accepts something, then we exit. Okay, we exit it. There's no need of break, we just exit. So the last one is the default. Okay, we say case, we don't need case, we just say default. Okay, the default is if nothing is entered. For example, nothing is entered, then we are saying exit. Okay, we are just saying calling the exit with exit underscore failure. Okay, or exit with underscore failure, which means we do not put anything. All right, and we press enter and close the curly brace. Okay, so this is nice. So if this program is clean and is working fine, then everything should be good to go. So this exit function is like we do not include the other files of it, which is std_lib. Okay, yeah, we didn't, so I will just include that, because if we not include it, it will give us error. So we just include that. We call it std_lib.h, and we close this. So this is it. This is this program. Okay, so this is a time clock program, and it's very pretty good and nice looking. So if we have any error here, we'll just come back and fix it. So I will just save this file. Okay, and that's it. So the next thing is to compile. Use GCC. We can as well also use the CC compiler. Okay, let's use the CC compiler, or the pretty one everyone is more familiar with, which is the GCC. Okay, the difference between GCC and CC is that this CC is the first one, is created by Dennis Ritchie, while the GCC is created by the GNU community. So people all over the world contribute in writing this code, building this GCC, while this one was created by Dennis Ritchie and Ken Thompson, okay, in the 1978, okay, at AT&T Bell Lab. So we can use this, or we can still use this one. So let us use the GCC created by the community itself. So we say GCC, we say digital clock.c. We are outputting it to give it just the name digital clock. Okay, so we'll remove the .c here, and I'll press my enter key. So if everything works fine, we have a very nice cool compile code. Okay, we have error here, and the error here is based on my typing. I made a mistake. You can see it's supposed to be 2 equal to an n, not m. So we just go back and fix that. I for insertion key, I will just go to that line of code. I know where is it. So it's up, up. Okay, this is where I'm making the mistake. Can you guys see it? So I'll just remove 1 equals to, and this shouldn't be m, this should be n. Okay, yeah, this should be n. All right, so escape, and that is it. So I clear the screen and I compile again. All right, the code compiles now without no error. So ls, we have our digital clock. So it's time to run this digital clock program. So we do /digital clock and press my enter key. Now you see clear the screen and our program starts. Okay, you see you have menu, clock count, digital clock. So we say enter choice. We assume that we're entering 0, for example. That means our program is going to terminate, and you see it's terminate by saying, okay, say input, incorrect input. Okay, that is a runtime error. But let us just run this program by giving it 1. It cleared the screen again. We say, let's say we pass in 1. We press enter. You say incorrect. Okay, so let's go and fix that error. Okay, say vim digit.c. Let's go and fix that error. So you say if n is equals to 1, or n is equals to 0, or n is equals to 2. All right. Okay, if n is not equals to, that should be, what is equals to, we should have the incorrect. Okay, so guys, that is my problem. You see, we should say if n is not equals to 1, okay, any of these can be correct. If n is not equals to 1, okay, I've seen the problem here. It's based on this condition, that's why it's exiting. So our code is being trapped inside this print incorrect input and exit. So it's just based on our logic comparison operator here. So we are trying to compare 3 things, and the first one here, we say if n, so whatever I give to n, for example, if I give n 0 and n is equals to 0, it will just say incorrect. Okay, so I want in the case whereby if I say this, okay, let it we don't want to end up inside this loop. Okay, we don't want in a case whereby we end up inside this loop. So what I will just do is that I can just fix everything inside this if statement. Okay, that will work very fine if I fix everything inside this if, inside the else statement. Okay, so but we are just going to do it one after another. We're going to do it one after another. If n is less than 1, okay, so whatever value that n is, enter, and is less than, say if n is less than 1, then we enter okay, and we close this, so we are supposed to say if n is not equals to 1. So if n is not equals to 1, then we are entering this. So we close, we remove this. So we did our first condition text, and we come here again, we say else, we say if else, if n is not equals to 0. Okay, if n is not equals to 0, then we also do the same thing by doing, we are printing, okay, we are printing if for example we wrote this thing as a function as incorrect, it would be more easy for me, but there's no need for that. That will just take much time. I think we do better at, even though that's okay, let's say we say incorrect in time for spelling error, guys. So you say incorrect input and /n, and that is it. And we exit as well with what? The exit code of exit failure. Okay, exit failure. Yeah, and we close this and put semicolon. Press enter and we close. We'll press enter again and do the last else if you see n not equals to the first one was 1, right? So we are going to do this one as 2. So not if it's equals to 2. Okay, if it's equals to 2, then we enter. We also print to the screen, say incorrect input. Okay, /n and this, and we are making a mistake here. I'll put this like this. So that is it. So we close this, semicolon, pass in exit, open bracket, exit underscore failure, and we close this and we put semicolon, press enter and we close. So that's it. But if everything work fine, then we say else. Everything work fine, then we are printing to the screen. Okay, we say found. Say found. Okay, we don't need this found though. Let us just take it off. Okay, let the program just do what it's supposed to do. Okay, let's just print it though. We say else. If it's ugly, if it makes our program ugly, we just come and change that. We say else. We say found. Okay, /n and semicolon. Okay, and that is it. So let's go run this code, guys, and see if everything works fine. So we compile this. Yeah, press enter. Okay, so not equals to match this. Okay, oh my goodness, you see what typing error is doing to me. So press enter. So look at what I did here. I'm supposed to put semicolon. I went and put I. So this should be semicolon, and at the up here, look at my comparison at the first one. Look at, I went and put minus instead of equal to. Put equal to. Okay, let's run this code now and escape shift colon WQ. Escape shift colon WQ. All right, clear the screen and we compile again, and everything will compile fine. Now it works. So we run our program ./digit, press enter, it clear the screen. Let's say we say 0 and it say input incorrect. The code is still giving us that error. It's still giving us this error. Okay. Okay, we say if it's less than, let's put less than in here also. Let's say less than. No, let's say if it's less than also, and here let's say if it's greater than. Greater. So let's compile. The logic compilation there is what is just disturbing us. So press enter, it compiles. So let's run it now and see. So if we say 0, I think we're not supposed to have that error. If it's less than 0, if it's greater than 0, okay, let's run this code. Let's try it again. Let us. What am I missing? What am I missing? I'm missing this comparison. Okay. Oh my goodness, guys. I'm the one making hell of mistakes here. Look at this is supposed to be a condition that don't need to be satisfied. Okay, it should be a condition that don't need to be satisfied. Okay, it should be a condition that don't need to be satisfied. Okay, so what I'm gonna do here is say it should be if n is equals to 1. Okay, if n is equals to 1, then the program works fine. Then we are not taking in anything. So let us take off all these things we just did here. Okay, let us take off all these things. Okay, let us just take off all these things we did. So we leave only this one. Okay, so we come here, we say if it's equals to 1, the condition is satisfied. We put or. What I'm doing now is what we work. If it's equals to 0, the condition is satisfied, or if n is equals to 2, then the condition is satisfied, which means whatever that is inside this bracket will be printed. And what we want it to print here is called, we should do the print elf, which we say found. Okay, that's what we want it to print. So we say found, open bracket. Sorry guys, I was the one making hell of mistake. I'm really sorry. So we say \n and we close this semicolon and we close this as well, and here will now be the else. If it's none of this, then we want this code here to execute. I hope this is understood. So let's run this code and we see everything will work perfect. So we compile it again. Okay, the switch statement expected identifier or return 0 expected. Okay, let's see. It's like this place there's something we left which we are supposed to not to leave. Okay, let's go down. Okay, yeah, this is it. We're supposed to I for insertion. We are supposed to put open curly brace here. Yeah, sorry, open curly brace, and that is it. That's why the switch was giving us error. So it compiles now. ./digit, enter, clear the frame, and start. If we say 0, then it will tell us found, you see, and program ends. Okay, you see, it works. So if we run the program again, we now say 1, then if we press enter, it will tell us found, then it's now start giving us the clock handle. Okay, now the clock is working, but it's not working apparently as we wanted, so we need to fix this error. Okay, so let's go straight and fix this error. So I'll just say Ctrl+C to terminate the program. Say vim digit.c. okay, so vim digit.c. So we go to the clock. The first one is what? On clock count. So what is our problem here in clock count? Okay, right, we flush 60 seconds, hours, and we sleep. Okay guys, so let's check what this error is all about. So guys, the error here, why we are getting those problems is, I think it should be because we do not declare the variable of seconds, minutes, and hour was not actually initialized. So I think that's why we are getting those bunch of number, because what happened is that whenever you declare a local variables, this once you do not initialize them value, the system automatically give them a garbage random numbers. So let's give it a declaration. So the declaration here will be at the top here. So we come here, I for insertion key, I'll press our enter key. There we see sec is equals to minute, and minute is equals to hour, and all are initialized to 0. Okay, 0. Okay, and we say this semicolon, and that is it for all. So we recompile this code again. Okay, and we recompile again by doing gcc, clear the screen, gcc digit.c minus digit. Okay, or press enter, and it compiles. So let's run our code. Okay, clear screen. So if we say 0 found and it exists, so we repeat again the program, it clear the screen, it starts with same 1. So we are going for count. Play. Now you can see it's incrementing. So at every slide it gives us output. This is a system clock count. Okay, all right, so that's it. So if we like do Ctrl+C to quit and we run the program again, we choose the number 2, which is digit clock. Let's see if it gives us the appropriate time. Okay, now my time is, if you look at the screen here, okay, if you look at the screen, look at the where the arrow is pointing, my time is 4:25, which is early morning, that is 25 minutes after 4. So if I choose number 2, okay, so I'll just off this, I'll choose number 2 to see if it gives us the actual clock of my time zone. Okay, now you see 6 say found 6 46:20. So 6 hours, this 46. So this clock is not working properly, is not working fine, so we have to fix this clock. Okay, so we go back to our code, vim digit .c, press enter. So we go back to the Yeah, we go back to downward. Yeah, this is the clock. Yeah, this is where we are facing our problem. So let us see the reason why it's not getting our current time zone. Let's see to that. So our error should be around here. Okay, so there's something we did not do. After we declare this time, we are supposed to pass in the time function to set it to a random number of null, which is 0. So I for insertion key, so we should have said x, okay, should be equal to time function, and in the time function we pass in null. Okay, and we close this and put semicolon. So that is what is happening to our code. And there's something I also like figure out in the time count. Okay, 60 seconds should be 1 minute. 60 should be equals to 0. No, seconds should not be equals to 0. Should second be equals to 0? Yeah, every 60 seconds. Yeah. Okay, let's run this code. Let's go compile this code. This is how I want this program to work, but it's not working that way though. But I will fix it before we end this this class. Okay, so we'll run this code. So we say we choose the number 2. Sorry, that was wrong input. So we say number 2. I will press enter. Now you see it's getting the clock. Now if you look at my original clock time zone, you can see it's 4:29. It's giving me 4:29. So the 47 at the beginning here is the seconds. Okay, is the seconds is ticking. So if I run this program again, for example, if I run this program again, for example, I press my enter key, I choose number 2, time will change. You see, if you look at the up time zone now, you see it's 4:30. Now it's 4:30 and 13 seconds. So this clock digital clock is working very fine. So you can be using these applications in your phone. So before we summarize, let's run the last aspect of the program, because there's something I will in the count there's something I would like us to face. Okay, if we choose number 1 for example, now it counts, like it keep reading, it's not flushing the memory. Okay, what I'm gonna do is that I'm gonna call the clear screen. Okay, inside this place this county. So when it clears the screen, we allow it to flush the buffer itself. Okay, so we do Ctrl C. I will go back to vim digit.c and we go down. So once the clock starts, okay, at the clock time here, once it starts, we would like to clear the screen. We like to clear the screen. Every fly it's counting. We clear the screen in every fly it's counting. Okay, so the error I want us to fix lastly is how it clears the screen. So once it flush the buffer, we would like it to as well clear the screen. So to do that, I have to call in this called clear function. So I will use the system call, the system C library, and I will pass in clear, because I want at every repeating let it clear the screen, so that we don't see all those counts keep counting over and over again. Okay, it doesn't look good. So that is all we need to add. Then this program is now working very fine. So we use the GCC digit.c output to digit, and we compile and we run our program. Digit, it clears the screen. We choose number 1. Then you can see how it will be counting now. You see, it will count just like this, and it will be counting. And how does this look? It looks really nice. So it's counting. So when it's up to 60 seconds, it becomes 1 minute, and the seconds keep counting. So let us allow it to count up to 60 seconds. So it will count. So as it counts 60 seconds every fly, it will be 1 minute, another 60 seconds, 2 minutes. If the minute reach up to 60, it become 1 hour. Okay, so that is it, guys. It's been education hanging out with you guys. My name is Ben, and this is a more real program, okay, written in C. Okay, and you guys see the way I do. I make sure that I fix every bug in the life, and anything I come across that based on my mistakes, I fix it in the code. Okay, so as well, you that is watching me, you can ask well. If you want to learn the C language, you can contact me, okay, on my TikTok channel at Hackbase, the same YouTube channel, the same TikTok. They are all using the same name, Hackbase, and you can contact me from TikTok. Or before the end of this video, I will just put my number. You can call me if you really want to learn. Now you see 60 seconds is now 1 minute. Okay, so thank you guys for subscribing. Okay, thank you guys for following me and watching my videos. I really appreciate. Okay, God bless you. Have a nice day. Bye. So if I press Ctrl C, the program stops, and that is it. See you guys on my next video. Bye.